All right, guys, what we're looking at here is an example from 2019 that deals with solids of revolution. Now, the one thing that I will say about this problem that you need to understand is that this is supposed to be done without a calculator. And so some of the points come from the, normally that we wouldn't get just from taking like antiderivatives and stuff. So just be aware of that as we look at this problem. So let's go ahead and jump on in. We look at what the problem's saying. We've got let R be the region enclosed by the graphs g of x equals -2 cosine of pi over 2, and then we've also got plus 3 cosine of pi over 2, and then we've got 6 minus 2x minus 1 squared. Now, you don't need to know, because you'll get it figured out real quick, that that's g of x and that's h of x right there. And then we've got this vertical line, x equals 2. So we've got this enclosed area, pretty straightforward as far as what it's asking us to do. Now, letter A wants us to find the area of R. So hopefully you remember area is just the integral from a to b, in this case from 0 to 2, of the top function, so that's -2 plus 3 cosine of pi halves x, minus the bottom function. So I get 6 minus 2x minus 1 squared, and then we've got dx. Now, normally we would just plug this into our calculator, but because this is on the non-calculator section, we actually have to do this by hand. So there's a couple things that will make that easier. First of all, I need to distribute this 6 through to everything right here. So that's how I distribute that. And then I would multiply out x minus 1 squared. You don't have to. In fact, let's actually do it without this time. But I can combine the -2 and the -6. So really this is just -8, and then I have the 3 cosine of pi halves x. So now what we have to do is take the antiderivative of everything. So I take the antiderivative of 3 cosine of pi halves x. That's 3 sine of pi halves x divided by pi halves. And then I've got minus 8x. And then I've got plus. The 2 stays there. And then the derivative of x minus 1 squared is x minus 1 to the third. And then technically we divide by 1. And then we have to plug in 0 and 2. So I take 2 and I plug it in. I get 3 sine of pi halves times 2 divided by pi halves minus 8 times 2 plus 2 times 2 minus 1 to the third power. And that's what we get when we plug in 2. Then we have to do the same thing with 0. 3 sine of pi halves times 0 over pi halves minus 8 times 0. And I realize that this does turn out to be 0, but it's better safe than sorry that you plug it in because it doesn't always equal 0. And then we subtract one from the other. Now that technically is your answer in this particular problem. And so what you get when you put all of that into your calculator, if you really want to know, if you simplify it down, you should get 44 thirds, which I believe if you put that in as a fraction into your calculator, again, this answer up here is fine, but if you put that in, you get 14.667 or something like that. That is your answer for letter A. And again, that one, there's a lot of work that goes into that since we don't have a calculator. Letter B says now we've got a cross section, has an area of a of x equals 1 over x to the third. Find the volume of the solid. So we're basically taking this and we've got this weird shape. We don't know what it is. I don't know what this is this time because it doesn't tell us. But it tells us the area of that shape coming off is 1 over x to the third. Well, remember, any time that we do a cross section, we just do the integral from a to b, so in this case from 0 to 2, of the area of the cross-sectional shape that's being talked about. In this case, it tells us that area formula is 1 over x to the third, and then we've got a dx on the bottom. Well, it wants us to find the volume of that, so I have to take the antiderivative just like I did before. That's the ln of the absolute value of x plus 3. From 0 to 2, I plug in the 2, so I get ln of 2 plus 3, which is 5, minus the ln of 0 plus 3, which is 3. And I just leave my answer like that. That's the volume of this particular cross-sectional shape that we're setting up. So again, hopefully that one kind of makes sense on how we did that. The trick here is knowing that they already gave us the area formula, so we just take the antiderivative of that. Letter C, we've got this line up here at x equals, or y equals 6, and we're going to revolve around that particular line. Now, the nice thing about this is we just have to set it up, but we don't have to do anything with it. So I put my pi on the outside, and I've got the integral from 0 to 2 of the radius that is further away is my 6 minus 2 times x minus 1 squared. So I'm going to have 6, the distance from that to the radius is 6 minus that h of x that we have, squared minus, then we have the function that's closer that we're revolving, that's 6 minus g of x squared dx. And you'll notice, again, we just have to set it up. We don't have to do anything with it. So we're actually all done with this particular question. Now, again, all of those without a calculator are very simple. With all of them, you would have gotten quite a few points just for setting stuff up in this problem. Like you probably could have gotten a 5 or 6 out of 10 even without doing very many antiderivatives at all, just by setting stuff up correctly. So just kind of keep that in mind, especially when you don't have a calculator. Don't get frustrated that you can't do a lot of the integration when you can do everything else like the setup and get quite a few points for those.